Hello, welcome to another module in this online course, Strategy and Introduction to Game Theory. So, let us continue our discussion on auctions. Let us start by looking at a sealed bid first price auction. So, let us begin our discussion on auctions by looking at a sealed bid first price first price auction. So, we consider a two-player auction. So, let us say we consider a two-player auction. Let us call these player 1 and player 2. These are the two players participating in the auction. And both these players submit their bids for the object being auctioned. Let us say their bids are B1 and B2. So, these players submit their bids. So, P1 comma P2 submit their individual bids B1 comma B2, they submit their individual bids B1 comma B2 respectively for the object being auctioned. And these bids are submitted in a sealed envelope, right? These bids are sealed, or these bids are submitted in sealed envelope. So, these bids are sealed. Therefore, the bid of each player is not known to the other player, right. So, the bid of each player is not known to the other player implies P1 does not know the bid B2 of player P2, and P2 similarly does not know the bid B1 of player P1, right. Therefore, each player does not know the bid of the other player. That is, P1 does not know B2 of player 2, and similarly P2 player 2 does not know B1 of player 1, or basically P1. So, P2, P1 and P2 both the players, they submit their bids B1 and B2 in sealed envelopes, right. So, which means they are not disclosing their bids to the other players. Therefore, P1 does not know the bid B2 of player 2, and P2, that is the second player, also does not know the bid B1 of player 1. And the auction mechanism is as follows: the player with the highest bid wins the auction, right. This is known as the first price auction. So, the player with the highest bid wins the auction, and he pays an amount equal to his bid to get the object. This is known as the first price auction. So, player with highest bid wins the auction and pays an amount equal to his bid to get the object being, so he pays an amount equal to the bid to get the object being auctioned. For instance, let us take an example. If B1 is greater than or equal to B2, if B1 is greater, that is bid of player 1 is greater than or equal to bid B2 of player 2, then this implies then P1 or player 1 wins the auction and pays his bid, which is B1, to get the object. However, player 2 with his bid B2 who has lost the auction does not pay anything. The other player who has lost the auction, that is player 2 who has lost the auction, does not pay anything. Player 2 who has lost the auction does not pay anything. Similarly, if B2 is greater than B1, on the other hand, if B2 is greater than B1, then player 2, that is P2, wins the auction, that is he wins the auction and pays his bid amount, that is B2, to get the object. So, if B2 is greater than B1, that is player 2 has bid higher than player 1, then player 2 gets the object and he pays his bid amount, that is B2, and player 1 who has lost the auction does not pay anything. Right. So, this is known as the first price auction. That is basically we are saying that is first price auction is an auction in which the player with the highest bid wins the auction and pays an amount equal to his bid value. So, this is known as a first price auction. Which is basically player with the highest bid wins the auction and pays an amount equal to his bid value to get the option, pays an amount equal to his bid value. Player with the highest bid wins the auction and pays an amount equal to his bid value. That is, if B1 is greater than or equal to B2, then player 1 wins the auction and he pays B1 to get the option, while player 2 does not pay anything. On the other hand, if B2 is greater than B1, then player 2 wins the auction and pays his bid amount B2 to get the object, and player 1 does not get anything. This is known as, this auction format or this auction mechanism is also known as a first price auction. Now, in addition to this bids B1 and B2 in an auction, each player has a private valuation for the object. So, in addition to their bids, each player has a private valuation for the object. What is a valuation? A valuation basically is how much the bidder values the object. The valuation is basically a valuation, simply put, a valuation is what value the player or the bidder player assigns to the object, right. So, each player has a private valuation, and this valuation is basically nothing but the value that the player assigns to the object, and this can be different from the bid. This need not be equal to the bid, that is, the player might bid differently and he might have a different value that he attaches to the object, right. And ultimately his aim is to secure the object or procure the object at a bid that is much lower than the value he places on it, so that he can make a profit out of it. So, let us call these different valuations, these different private valuations, valuations of player 1 and player 2. Let us say player 1 has a valuation V1 and player 2 has a valuation V2. What are V1 and V2? V1 and V2, these are the valuations, right. So, V1 and V2 are the valuations of player 1 and player 2 for the object being auctioned. So, V1 comma V2 are the valuations of player 1 comma player 2 respectively for the object these are the valuations of player 1 and player 2 respectively for the object being auctioned, and these valuations are private, which means player 1 does not know the valuation V2 of player 2 and player 2 does not know the valuation V1 of player 1. So, therefore, these valuations are private. Implies player 1 does not know the valuation V2 of player 2. Further, player 2 does not know the valuation V1. Further, player 2 does not know the valuation of player 1. So, each player does not know the valuation of the other, right. So, player 1 does not know V2, which is the valuation of player 2, and player 2 does not know V1, which is the valuation of player 1. Therefore, these are known as private valuations, right. And however, what is known is, let us say, some information related to these valuations, some statistical information. For instance, let us say that these valuations are distributed uniformly in the interval 0 to 1. So, what we are going to assume as that these valuations, these private valuations, or what is known is that these private valuations are distributed uniformly in what is known is that these private valuations are distributed uniformly in the interval 0 to 1. That is, the probability density of both V1 and V2 is uniform in the interval 0 to 1. This is what we have already seen, right. We have already seen an example of a uniform random variable in the interval 0 to 1, that is a random variable which is distributed uniformly in the interval 0 to 1, And what we are saying now is we are using this uniform random variable in the interval 0 to 1 to characterize the valuations V1 and V2. We are saying that the densities f of V1 and f of V2 are both follow a uniform random variable which is distributed uniformly in the interval 0 to 1. So, we are saying these valuations V1 and V2 are distributed uniformly in the interval 0 to 1, and what we wish to find is now the Nash equilibrium of this auction game or this Bayesian auction game. Now, you can clearly see why this auction game is Bayesian in nature, because there is uncertainty in this game. There is uncertainty regarding the valuations, right. So, each bidder or each player does not know the valuation of the other player, but he has certain probability or certain statistical information about the valuation or the type of the other player. So, in this context of an auction, if you were to think of it as a Bayesian game, you can think of the valuation of the other player as the type of the other player. So, each type of the other player has a different valuation, and you can see there is infinite number of types, because the valuation can take any real number between 0 to 1. So, this is a Bayesian game since there is uncertainty regarding the valuations of the other player. So, this game or this auction game is Bayesian in nature, since there is uncertainty regarding the valuations or valuation of the since there is uncertainty regarding the valuation of the other player. And therefore, we now have to analyze this game similar to the other games that we have considered before. We have to find what is the bidding strategy of each player of each type, right. Therefore, we have to come up with the Nash equilibrium bidding strategy of each player participating in the auction. So, we would like to analyze this game to find the Nash equilibrium bidding strategy of each player. So, we wish this game to find the Nash equilibrium we wish to analyze this game to find the Nash equilibrium bidding strategy of each player, right. At Nash equilibrium, what is the strategy employed by each bidder or each of these players in this first prize auction, right. And towards this, what we are going to demonstrate is that we are going to demonstrate that the bidding strategy. So, we will demonstrate that the bidding strategy B1 equals half V1 and B2 equals half V2 is the Nash equilibrium bidding strategy for this game. That is, B1 equals half V1, B2 equals half V2 are the Nash equilibrium bids for each player in this first prize auction. That is, where each player is bidding half his or her valuation is the Nash equilibrium bidding strategy. Therefore, half his valuation is the Nash equilibrium therefore, each player bidding half his valuation is the Nash equilibrium bidding strategy, right. So, how are we going to demonstrate this? Again similar to what we had done in the context of previous game, that is by showing that each player is playing his or her best response. That is, we want to demonstrate that at Nash equilibrium B1 equals half V1 is the best response to bid B2 equals half V2 of player 2, and similarly for player 2 B2 equals half V2 is the best response to B1 equals half V1 of player 1. So, we want to demonstrate that each of the players is playing his or her best response. That is, we want to demonstrate, we wish to demonstrate that B1 and B2, that is B1 equals half V1 and B2 equals half V2 are the best responses to each other. So, we wish to demonstrate, we wish to demonstrate that B1 equals half V1 and B2 equals half V2 are best responses to that B1 equals half V1 and B2 equals half V2 are the best responses to each other. Now, let us start by considering that player 2 is bidding B2 equals half V2, and let us find what is the best response B1 of player 1. So, let us assume that player 2 is bidding B2 equals half V2, and let us ask the question, what is the best response bid B of player 1. So, if indeed player 2 is bidding B2 equals half V2, what is the best response bid B of player 1, right. To find the best response bid B of player 1, we have to find the valuation, or we have to find the payoff to player 1 as a function of the bid B, and then we have to find the value of B or the bid B at which his payoff is maximized. So, first we have to find the payoff as a function of B, and we have to choose that particular value of B for which this payoff is maximized, and that is his best response bid B to the bid B2 equals half V2 of player 2. So, let us find the best response. So, now first let us start by finding the payoff of player 1 or the payoff to player 1 as a function of his bid B, right. So, let us denote this quantity by pi of B, that is pi of B denotes payoff to player 1 as a function of the bid B, and remember the payoff to the bid B, payoff to player 1 as a function of bid B depends on one of two scenarios, that is either player 1 wins the auction, right. If player 1 wins the auction, which means his bid B is higher than the bid B2. So, let us consider the first scenario, that is player 1, if player 1 wins the auction, and this corresponds to the scenario, that is bid B being higher than equal to B2, then his payoff is equal to, well, his payoff is equal to, because if he wins the auction with bid B, then he pays an amount equals to the bid B, right, and therefore he loses his bid B. However, he gains in terms of the valuation, because now he is going to get the object which has a valuation to which he attaches a value V1. So, his net payoff is V1 minus the amount paid, which is the bid B. So, his net payoff is V1, that is his valuation minus the bid amount B. So, net payoff equals V1 minus B. V1 is this valuation, while bid B is the bid paid on winning the auction. So, he has paid an amount B to get the object, and he has a value of V1 for the object. So, his net profit or his net payoff is V1 minus B if he wins the auction. On the other hand, if he loses the auction, that is, if B is less than or equal to bid B2 of player 2, then his net payoff is 0, because he does not pay anything and neither does he get the object. So, his net payoff is 0. So, if he loses the auction, if player 1 loses then his payoff is 0, because he does not pay anything and neither does he get the object. So, if he loses the auction, if player 1 loses the auction, which occurs when his bid B is less than or equal to or less than the bid B2 of player 2, then he loses the auction, he does not pay anything, right. So, then the the amount paid by him is 0, neither does he get the object. So, therefore, his net payoff is 0. So, therefore, the average payoff of player 1, average payoff to player 1 is given as probability winning, that probability he wins the auction times V1 minus B, because his payoff if he wins the auction is V1 minus B, plus the probability that he loses the auction, the probability of loss times 0, because if he loses the auction, his net payoff is 0, right. So, what are we saying? We are saying that if he wins the auction, then his payoff is V1 minus B, that is valuation V1 minus bid amount B paid, right, and therefore, we are multiplying that by the probability of winning times V1 minus B, plus the probability of loss times 0, because if he loses the auction, then he does not get the option, does not get the object, and neither does he pay anything, right. So, on the net profit on loss of auction is 0, which means the average profit or the average payoff is probability of winning times V1 minus B plus probability of loss times 0, which can be simplified as probability of win times V1 minus B, right. So, net payoff pi B to player B equals the probability of winning the auction times V1 minus B. So, the payoff, what is pi of B? Payoff to player 1 as a function of bid B. So, pi of B, which is the payoff to player 1 as a function of the bid B, is equal to the probability of winning times V1 minus B. It now remains to find what this quantity probability of winning this, that is, as a function of the bid B, what is the probability that he wins the auction? As a function of B, what is the probability of winning the auction? What is PR win, that is the probability what is PR win, that is the probability of winning the auction. Remember, to win the auction, the bid B must be greater than or equal to bid B2 of player 2, but B2 of player 2, remember we had assumed B2 is equal to half V2. So, to win the auction, bid B, that is to win, we must have to win, or for player 1 to win, we must have B greater than or equal to B2 equals half of V2. So, we must have for player 1 to win, B must be greater than or equal to half V2, which implies that V2 less than or equal to 2B, right. So, to win the auction, bid B must be greater than or equal to half V2, which means V2 must be less than or equal to twice B. Therefore, it means that V2, which is, remember, the valuations are uniformly distributed in the interval 0 to 1. Therefore, it means that V2 must lie in the interval 0 to 2V. Since the valuation V2 is distributed uniformly in 0 to 1, we must have V2 in, or V2 in 0 to 2B. Therefore, if V2 is less than or equal to 2B, that is for player 1 to win the auction, it must be the case that V1 lies in 0 to 2B. And what is the probability that V2 lies in 0 to 2B? The probability, remember, probability V2 lies in 0 to 2B is equal to the integral 0 to 2B f of V2, that is the probability density of f of V2 integrated between 0 to 2B. But between 0 to 2B, since this interval is contained in the interval 0 to 1, the probability density is 1. Therefore, we can write this as 0 to 2B 1 times dV2, which is V2 integrated between the limit 0 to 2B, which is equal to 2B, right. And therefore, what we have shown is that the probability that the valuation V2 of player 2 lies in the interval 0 to 2B is equal to 2B, and therefore, this is the probability that player 1 wins the auction. Therefore, the probability of win for player 1 as a function of his bid is equal to probability of win for player 1 as a function of his bid B is 2B. And therefore, now if we go back to this expression over here where we are characterizing the payoff, we now know the probability of win. The probability of win is 2B as a function of his bid B. Therefore, the net payoff pi of B, therefore, pi of B is, that is the net payoff pi of B to player 1 as a function of his bid B is pi of B equals the probability of winning 2B times V1 minus B, which is the payoff on winning, which is equal to 2B V1 minus 2b square. So, pi of b, which is the payoff to player 1 as a function of his bid b, is 2b v1 minus 2b square. Now, we have the payoff as a function of b. We have to find the b for which the payoff is maximum. For this purpose, we have to differentiate this function of b and set it equal to 0, and thereby solve it to find the value, the best response b. So, dou pi b. So, we have pi of b equals 2b v1 minus 2b v1 minus 2b square. Therefore, dou pi of b by dou b equals twice v1 minus 4 times b, which we equate to 0, which implies, gives us the result that b equals half v1. That is the best response bid b star is equal to half v1. So, what have we shown? We have shown that if b2 is bidding, player 2 is bidding b2 equals half v2, then the bid b star equals half v1 is the best response bid of player 1. So, if b2 equals half v2, then the bid b1 equals half v1 is the best response of player 1, right. Similarly, by symmetry, it can be shown that if b1 is bidding, if player 1 is bidding b1 equals half v1, b2 equals half v2 is the best response for player 2, using a similar procedure, in fact repeating the same procedure, using a similar procedure. It can be shown that if b1 equals half v1, that is player 1 is bidding b1 equals half v1, then b2 equals half v2 is the best response of player 2, right. So, what we have shown is that if b2 is bidding, if player 2 is bidding b2 equals half v2, then b1 equals half v1 is the best response of player 1. Similarly, we can show that if player 1 is bidding b1 equals half v1, then b2 equals half v2 is the best response bid of player 2, and therefore, since these bids b1 equals half v1 and b2 equals half v2 are best responses to each other, this is the Nash equilibrium of this first prize auction game. Therefore, we have P1 equals half V1 comma B2 equals half V2 are best responses to each other, right. These are the best responses to each other. Therefore, B1 equals half V1 and V2 equals half V2 is the Nash equilibrium of this first prize auction. So, this is the Nash equilibrium of our sealed bid therefore, this is the Nash equilibrium of our sealed bid first prize auction. That is what we are saying is, in the sealed bid first prize auction, in which the two players, that is the two players P1 and P2, or also known as the bidders, submit their bids in sealed envelopes, that is the bid of each player is unknown to the other, with valuations, with private valuations V1 and V2 distributed uniformly in the interval 0 to 1. The Nash equilibrium for this Bayesian sealed bid first price auction is B1 equals half V1 and B2 equals half V2. So, let us stop with this Bayesian Nash equilibrium, derivation of the Nash equilibrium here, and we will continue our discussion on this auction format in the next module. Thank you.